except now you just have to write a sentence instead of just a row in your two columns. Okay, so paragraph proofs are writing sentences to explain why the conclusion is true. Okay, each sentence cites the reason justifying why it is true. Okay, so each row in that two-column proof would be a sentence. Okay, so you'd make out that sentence for each one. Okay, and that would just create your paragraph. Okay, reasons are definitions, algebraic properties, postulates, or theorems. So a statement that can be proven true is a theorem. Okay, so you're still using these definitions, properties, postulates, and theorems from your list or from your packet. Okay, so you're still using those same properties. So we're going to go over this with a little bit more structure. I kind of have the sentences written out and you just have to fill in the blanks. So in the figure, segment AE is congruent to segment DB, and C is the midpoint of AE and DB. Okay, we have to write a paragraph proof to show that AC is equal to CB. So I want you to rewrite your given so you know what information you're given from that. So in our figure, we have segment AE is congruent to segment DB. Okay, we also have C is the midpoint, and I'm going to abbreviate midpoint. You don't have to, but okay, C is the midpoint of AE and DB. Okay, and what we have to prove is that AC is equal to CB. So now that I've got that written out, I want to label that in my picture. So I know that AE is congruent to DB. So however you need to label that, okay, so this segment and this segment, those two larger segments there are congruent to each other. Okay, and C is the midpoint of AE. So what do I know about these two segments? If C is the midpoint, they're congruent, right? Okay, whatever I label, I have to include in my proof somewhere. So since I labeled that those are congruent, that has to be written in my proof somewhere. Now, C is also the midpoint of DB, right? So since C is that midpoint, then again I can conclude that those two segments are congruent. Okay, so now that I have my picture labeled, we're going to start going through this proof. So just like with a two-column proof, you always want to start with your given, and with that given, you can make another statement. So here I would say since C is the midpoint, okay, C is the midpoint of AE. So I want to use C as the midpoint of AE. Well, I labeled on my picture that those two segments are equal, so I want to say that next. Okay, so I would say CA is equal to CE, which is also equal to 1/2 the length of the entire segment, which is AE. Okay, and that is by the midpoint theorem. Okay, so whenever you're given a midpoint, you're using that midpoint theorem to state that those two segments are equal. Okay, so I only use C as the midpoint of AE so far. So now I want to use C as the midpoint of DB. Okay, so since C is the midpoint of DB, which segments did I label equal to each other? from that midpoint. So C is the midpoint of DB. Which two segments are equal? Yes. Okay, so DC will equal CB, which is also just 1/2 of our entire segment. Okay, what theorem am I using to state that those are equal segments? The midpoint theorem. Okay, now I still have to use that third piece that I was given. Okay, so now I've used C as the midpoint of AE and C as the midpoint of DB, but I haven't used this part yet. So since segment AE is congruent to segment DB, I'm next using the definition of congruent segments. Okay, if I use the definition of congruent segments, what is my next statement going to be here? Using this. That AE is equal to DB. Okay, changing from congruent segments to equal measures. Okay, then by the multiplication property of equality, meaning I'm multiplying the same thing on both sides of that equation. Okay, so I'm taking this equation and I'm multiplying the same thing to both sides. Now that same thing is going to be this 1/2. Okay, so since I have 1/2 DB, I have also 1/2 AE. Okay, you're multiplying that 1/2 to both sides of that equation. So next I would use substitution. Okay, so that means I'm taking this last statement I made and I'm replacing it, okay, with something that is equal to. So I want to look further up in my proof and see what 1/2 DB is equal to. Okay, so that's right here. So it's equal to CB and DC. Well, here, since I'm ending my proof, right, I know my last statement has to be what I'm trying to prove. Okay, so I'm replacing 1/2 AE with what it's equal to, and that is AC or CA, same thing. That's right here. So replacing 1/2 DB with what it's equal to, I would replace it with CB because that's what I'm trying to prove. Okay, so it kind of lays it out for you. Sometimes it gives you the reason, sometimes it gives you the statement, and you still have to come up with that reason. Does that make sense? You're still doing the same thing, just with sentences now. Okay, questions on how I did any of those steps there? All right, this one's a little bit shorter. So we have triangle ABC where BD is an angle bisector. Okay, what do you know about an angle bisector? It splits it into two congruent parts. Okay, so if that segment is an angle bisector, that means it's splitting this angle into two congruent angles, and that's what's labeled in that triangle. So we want to write a paragraph proof to show that angle ABD is congruent to angle CBD. Okay? So those are already labeled for us. So we're just writing that. So first I want to start off with what we're given. Okay? Right here, this is what I'm given. I was given that BD is an angle bisector. Okay, and I'm trying to prove those two angles are congruent. Okay, so angle ABD is congruent to angle CBD. All right, so then I want to start my paragraph using that given information. So by definition, an angle bisector, because that's what I was given, an angle bisector, divides an angle into how many congruent angles? 2. Okay, so we're using that definition. Since segment BD is an angle bisector, angle ABC, so this larger angle here, is divided into 2 congruent angles. And therefore, our 2 angles we were trying to prove are congruent. Okay, questions on that one? That one make a little more sense? Only like 3 sentences? All right, try number 1 on the back. Again, it's 1 sentence. So write out what you're given, write out what you have to prove, and then come up with those blank spaces there. If you need to, get out your property list that I gave you a couple days ago, so you can just look back at that and check your properties. Oh, I can get you one. All right, so this one was short. So you are given that angle A is congruent to angle D, and angle D is congruent to angle E. And you have to prove that angle A is congruent to angle E. Okay, so you always want to still start with that given information. So since angle A is congruent to angle D, and again, what we're given here, angle D is congruent to angle E. Okay, those are given. You can either use 2 different answers here, substitution, or you can use transitive. Okay, you can use the substitution property to conclude that angle A is congruent to angle E. So either or, if you wrote transitive, you're also correct. If you wrote substitution, that is correct as well. So number 2 is exactly the same as the first one that we did. So number 2 is exactly the same as the first one that we did. So I want you to try and fill that in. Okay, so it's a little bit longer, but look back at the first problem that we did. Okay, look back at the first one that we did. Yeah. And fill that one in now too. Has to do with midpoints. It's that one. Just be aware it's not like this. I'm going to explain what to do in the third one for that one, for those. So, starting off this proof here, since most people were almost done or they're completely done with the last one already, I'm going to start going through this. So, since M is the midpoint of BC, okay, MB is going to be equal to 1/2 that entire segment length. So that is BC. Okay, MB is 1/2 of that entire segment length. Okay, and that is by the midpoint theorem. Okay, so now I've used one part of my given. I'll use another part here. So since n is the midpoint of EF, then I can say EN is 1/2 of that entire segment EF. And again, that is by the midpoint theorem. So whenever you use a midpoint, you're going to use the midpoint theorem to make that statement. Okay, it is given that these two segments are congruent. So using definition of congruent segments, I need to switch that from congruency to equal measures. Okay, then using that statement, BC equals EF, I can use the multiplication property of equality and multiply the same number to both sides. Okay, multiplying the same number there would be 1/2. So I have 1/2 BC, and I'll have 1/2 EF. Okay, then using substitution, I want to replace each of those with something that they're equal to. So 1/2 BC is equal to MB, and 1/2 EF is equal to EN. And that is what I was trying to prove up here. Okay, questions on that one? All right, so for the last one, yes, it's structured the same as the previous ones we've done, but in your assignment, I don't have them structured this way, so I'm going to show you how to kind of structure it without all of those words already in there. So what you can do is actually create a 2-column proof, okay? So I'm going to use it in the space up here. So we have our statements and our reasons. Okay, and the ones on your assignment are really short. Okay, the ones on your assignment are really short. So here I'm given S is the midpoint of QP. Okay, so I would label those two segments congruent, okay, in my picture. I'm also given T is the midpoint of PR. So again, labeling those. And P is the midpoint of ST. So these two are actually congruent to each other as well. Okay, so we want to show that QS is equal to TR. So just writing that out really quick. Okay, proving QS equal to TR. Now before I even start this, I'm going to write down my statements and my reasons. So I would start with a piece of my given information. Okay, so I'm going to start with S is the midpoint of QP. And that's given. Right? So using that statement, I want to create another statement. Well, since S was the midpoint, what did I label on my picture? S is the midpoint. I labeled these two segments are equal, correct? So I can say that QS is equal to SP. Why can I say that? I used a midpoint. Why can I say that? Midpoint theorem. Okay, so I'm just sketching out that 2-column proof. So this whole statement right here can be one sentence. So I would say since S is the midpoint of QP, then QS equals SP by the midpoint theorem. That is one sentence of your proof. Does that make sense? Yeah? Okay, then I would just move on from there. Okay, use the next piece of your given. With this one, we actually want to use P as the midpoint of ST. This is supposed to be a 2, this is a 3. That's given. And I want to use what I labeled in my picture to say that. So since P is the midpoint of ST, I knew these two segments were equal. So I would say SP is equal to PT. And again, that is by the midpoint theorem because I'm using that midpoint. You see I'm structuring this? Yes? You're with me? So from here, I used these two because I knew I had an SP and an SP. Okay? So if both of these statements have an SP, aren't these two equal to each other? Right? So then I would have QS equals PT, either by substitution or transitive. And I'm going to run out of room. So that's how I want you to structure it on your assignment. So create that 2-column proof and then make your sentences out of that. Okay, and the ones on your assignment, there's only 2. They're shorter than this one. Okay, so I'm just going to keep going into the actual proof down here so you can see what's going on. So using my 2-column proof, I had S is the midpoint of QP and P is the midpoint of ST. So I can say QS equals SP. Okay, that's where I used S as the midpoint. Now using P as the midpoint of ST, we said SP is equal to PT. And both of those were because of the midpoint theorem. Okay, then moving on, my next statement, I did use substitution. So by the substitution property, if I look here, both have an SP, so these two must be equal to each other. Okay, I still have to use that last midpoint, so I would have done that over here too. So T is the midpoint of PR. So since T is that midpoint, I can say those two pieces are equal, which is PT and TR. Again, that is the midpoint theorem. Okay, so using that last statement and this one above, both of these have a PT, so these two must be equal. So that is either by substitution or transitive. And again, that would be QS is equal to TR.